Welcome to Learn Animatronics. In this episode, we're looking at NeoPixels. Those are the special LEDs inside of this lightsaber that I built. There's 42 of them in here, and the light is being diffused through this shower curtain rod cover that I put on this child's toy. So for now, the toy is just hollowed out and the cord comes out the back. But in the future, you could make a pretty cool looking saber hilt here with all the electronics inside, and I'm sure you've got many other projects in store for these LEDs, so let's get started. This is what a NeoPixel strip looks like. We're going to call them NeoPixels, but they're actually called individually addressable LEDs. But there's a website called Adafruit. I'd really advise you to take a look at that. It's a great website. They've got not only products like these LEDs, but they've got tutorials and code for you. Very, very good website, so I'll link that in the description below. These NeoPixel strips use only 3 wires. There's a digital wire, which is a signal wire, and a positive and a negative. And they don't always come in this arrangement. Sometimes the signal wire is in the middle, and in that case, you just put the signal wire there. But when you hook up power to this, like there's a 5 volt, the whole line now has 5 volts, and the ground then has ground if you hook up ground to that. And then your signal wire only goes to the first one first and checks to see if that's the LED you want to activate. If it isn't, it bumps over to the next one and the next one and so on. And you can see there's an arrow here. It follows this line all the way down. And there's an in and an out, so all the way through the whole strip. Now, if you ever want to cut these NeoPixels and just use 2 or 3 of them instead of the whole strip, you can just cut them down the center here between these sets of pads and just solder on your own wires onto the little pads that they have. So super easy to hook up. They are amazing LEDs. They're very bright, and you can go from a brightness level of 0 to 255 for each one of the colors in here. And let's just talk a little bit about what these can look like when you purchase them. So they can either be in a strip, or you can get mini strips like this that are all on a hard surface PC board like that, where you just hook up 3 wires on the end. Here you've got digital in, your 5 volts, and your ground. You've got an extra ground if you need to do that as well. You can also buy them in circles, various amount of LEDs in the circle and sizes, and you can buy them in a matrix. This is a sheet of LEDs that you can get, and you can break off individual ones, and that's what I used on my maker sign. I'll show you that at the end of the video. You could also just keep it as a matrix and have it like a 3x5 if you're going to do something like a magic panel for an R2-D2 or anything that requires a flat surface with a bunch of LEDs on it. Let's talk a little bit about how to power these things. You can use battery packs, you can use wall adapters. If you are going to use a wall adapter, here's our 4 things that you need to keep in mind when either purchasing a wall adapter or even just using a wall adapter off of a different device that you no longer need. So you can definitely do that. I've got a bin of wall adapters, various voltages that I use, and I can just pull from that. The first thing you need to think about is your voltage. These LED strips require 5 volts. So be sure not to go over 5 volts because you'll damage them. They'll probably burn out prematurely. So you want to make sure that your wall adapter says 5 volts on it. The next thing is the current. So each of these takes a certain amount of current, and the current required is something I'm going to show you how to calculate in just a minute. But there's always a current sign on here. So this one says 3 amps. So that's important to know what the current is. And then the barrel jack size, when you're plugging this in either to an Arduino or to one of those terminal strips plugs, you can make sure that they're going to fit. So we'll look at that. And then the polarity of the plug, which part of it is positive and which one's negative. So in terms of that, this is what a barrel jack looks like. They're very common. You can get various sizes. So when you're purchasing one, make sure you get one the right size. This little diagram that's on the adapter, it tells you whether the outer casing is negative or positive, and I tend to always use negative on the outside and positive on the inside. And then for the size, this is a very common one. It's 5.5 by 2.1. That means the outer diameter is 5.5 millimeters and the inner diameter is 2.1 millimeters. And those ones fit into most Arduino related products. Say you have a wall adapter at home, got the right voltage and the right amps for something you're building with NeoPixels. Well, you can cut the end off of it and you can solder it onto these. This is a kit you can buy with a bunch of plugs and female connectors, and then you can just have your own set here ready to go for any wall adapters that someone gives you or you have off of something different. How do you know how many amps you need on your wall adapter? Well, let's take a look first of all at a NeoPixel. So one of these has a little controller in it, so it's waiting for a signal. It also has a red, green, and a blue LED in there, limiting resistor as well, so it's all built in. And when you turn on an LED strip full power, say to green, so I said it can go from 0 to 255, so it's at 255 green, this little LED will be drawing about 20 milliamps. Same with the red and same with the blue. So if you had all of these on full brightness, you would get a white light and this whole LED would draw 60 milliamps of current. So take a look at this strip here. We've got 10 NeoPixels and each pixel would need 60 milliamps at full brightness, so that would be bright white. So all you do is you multiply that by 10. 10 times 60 is 600 milliamps. That's what you need for your wall adapter. And if you want to convert that into amps, you just divide by 1,000, so it'd be a 0.6 amp wall adapter. And this wall adapter here is good to up to 3 amps. Remember, it's always good to have the right amount of amps or even more. So if this had like a 10 amp 5 volt, that'd be even better, because then this wall adapter is not working that hard. More amps is good, but more voltage is not. So that's something to keep in mind. For our LED strip that we put in the lightsaber, or the one that on the Uno, it has 30 NeoPixels. So I'm going to need a wall adapter that's good for at least 1.8 amps, or a battery pack that can provide that. This wall adapter that I have right here, that would be adequate because it's got up to 3 amps. This is the Adafruit website, specifically their area that talks about NeoPixels. It's their Uber guide. All of this information is very valuable. So you can take a look at the basic connections, best practices, powering NeoPixels. So a lot of the stuff that I'm going to be sharing with you just came from the site, as well as some code. And the best way to wire these NeoPixels up. So I'll go over this diagram with you next. But I just wanted you to be aware of this. This is a great place for you to start if you're really into learning more about NeoPixels. This is a basic wiring diagram provided by Adafruit, so thank you Adafruit for that. Very simple. All you need is a power supply for your device, which is the NeoPixel strip. You have to remember that microcontrollers like this are not designed to power things, they're used to control things. So you don't want to power the strip from the microcontroller, because the USB power that's coming in here, or even something from your barrel jack, is not going to be able to provide enough power for a larger strip or many servos and tons of LEDs. You can probably do maybe 2 or 3 NeoPixels from here, maybe 1 or 2 servos or a few LEDs. But basically what you want to do is provide separate power to your device. But you also want to tell the Arduino that you're using a separate power supply, and that's by connecting a ground wire to the Arduino, same ground that goes to your device. I call that holding hands, so that they're playing well with each other and they understand what's going on. So you just hook up power to power, negative to negative here, and your signal wire that comes into your strip needs to have a resistor on it. And that's going to be anywhere between 300 and 500 ohms. And you just hook it up to any digital pin that you want. And in this case, it's digital pin number 6. And then the other thing that you need is, in case of a power surge, because this might take a lot of power when it's started up for the first time, is a capacitor. Now these capacitors are designed for that. They have a positive and negative leads on them, and I'll show you that in more detail when we hook it up to the Arduino Uno. And you want your positive to go into the positive rail of your power supply and the negative into the negative. And anywhere between a 500 microfarad and a 1000 microfarad capacitor is what you need. So make sure that's plugged in. You've got your resistor plugged in. Then all you need to do is plug in your USB port to give power to your Arduino, and then your code will take care of the rest. And I'll show you some pretty cool code that you can use with these LED strips. If you don't have any NeoPixels right now, don't worry. You can go to Tinkercad and create this circuit. input the sketch and watch everything work. Right now I've got a circuit opened in Tinkercad, and if you're not familiar with Tinkercad, just go to my last video, and in that video I show you how to design circuits and bring in parts and try out sketches. So I've already saved this as NeoPixel sketch, you can see right up here, and I have all of the parts that I need in it. I've got a 3 battery pack here, so all I did is I went over to the battery, and over in the count, I changed that to 3. Let me just switch it over to 3 here, like that, and then you just click on it, and then you rotate it by hitting the R key and put it in place, and then you can wire it up. So let me just zoom in here. You just have your red going to the red rail, negative to the negative, and then your capacitor, if you hover over it, you can see that there's a positive and a negative, and you just put them into the appropriate rails. Now, if you can't find the capacitor, you want to switch from here to all, and then you have your capacitor showing up right there. So you can change the microfarads in here, so you can add that if you want. Probably should. You should change it to 1,000 and change that, up here, change that to 1,000 microfarads, and then you're good to go. So that's the capacitor. Let's get rid of that. As far as our LED strip goes, our input is going to the resistor. Positive is going to the positive rail, negative is going to the negative rail, so it's going to get 4.5 volts. Now, I used 3 batteries because that will create 4.5, which is close to 5, but you don't want to go over 5, so you don't want to put a 4 battery pack in here. The resistor can be anywhere from 300 ohms to 500 ohms, so I'll let you choose which resistor you want. They'll all work. And then I'm going into digital pin 3. So if I activate this, because I've already got my sketch loaded into here, into the code, you can watch it work. So let's just click Start Simulation, plugs in, and you can see these LEDs are all changing colors and with various different functions. It's not as dramatic as with a real NeoPixel strip, but you get the idea, and you can test it out here and make sure it's working before you wire it all up on an actual Arduino. It is time to check this out on a real Arduino. I've got my circuit all set up here. I have my electrolytic capacitor, and it's a 1,000 microfarad capacitor, and you can see that it's got a negative leg right here. That negative leg needs to go into the negative rail. So let's pop that sucker in here so that it's take up any extra surge of power if that happens. I've got my battery pack hooked up. I just have to pop that battery in when we're ready to go. Here's a couple NeoPixel parts that I thought I'd show you. This is one I just got off the internet. It has your 3 connector, and then it's got a 3 that goes out to another set of these if you want. So that's pretty cool. These are the ones that are individual. You can snap them off so that they're all on their own, and they have their connectors on the back. And I've used those quite a bit in different builds. This is one I'm going to show you here from Adafruit. It's got the little star symbol down here. That's the Adafruit symbol. On the back, you've got your connectors. So I've just soldered some wires onto there. So let's plug those guys in and see how this strip will work. So I'm going to just plug in my power, my ground, anywhere along that rail, and my resistor data pin. And let's pop this battery pack in, and you can see that we have scanning LEDs. Now, by the way, you can reset your Arduino, so there's no off switch on here, but you can press the reset button back here and it'll start the sketch over again. So there's red, green, blue, and then it just scans through all of the colors individually on each pixel. So that's pretty cool. Right now I've got the brightness level set to 100 out of 255, so this might be still a bit too bright for the camera, but you can see now they're doing a marquee style scan. So that's neat. This is a really cool little unit. You can use it on all sorts of robotic projects, and I've used them considerably in the past. So we're going to pop this one out. We're going to bring in one that is longer, and that's the one I used in my lightsaber build. So let's take a look at that. That's this long one. It's got 30 NeoPixels on it. Okay. Now let's take a look at the ends on this thing here. This end is your male end. You can plug that into another strip like this. So just continue on the sequence. This one here is the female end, and I've just plugged in some jumper wires. So what we're going to do is we're just going to hook that up. We're going to put our positive into positive, negative into negative, and then our data wire plugs right into the signal. So there we go. We have 8 blinky lights on this set of 30. So how do we activate the other ones? Now, that's a good question. Let's go over to the code and I will show you how to do that. And in this code here, you can see that we have this line right here. It says NumPixels equals 8. We want to change that to 30 and re-upload the code. So let's go to upload here, click on that, and then we'll take a look at our strip. And sure enough, all of the LEDs are now lit up. They're changing through. Actually, let's start it over again. You can see the whole sequence. So we have red, green, blue, and then each pixel is going through the function where it just scans through all the colors. And then it'll go into the marquee style. Here we go. It's a little bit better, like that. Awesome. So what we're going to do now is take a look at the code and see how we can create some pretty amazing special effects. And by the end of the video, I'll show you some that are really cool, like fire and maybe twinkling lights and stuff like that. So let's go check that out. Okay, let's dive into the code. This is just a basic code to get you up and running with the NeoPixels, and then we'll do some more complicated sketches. If you take a look at this basic sketch that I have, you can see that all of this is just a comment. It just tells you a little bit about NeoPixels, different types, and reminds you that 1,000 microfarad capacitors and a resistor is a good thing to have in your circuit, just to take good care of it, protect it. So none of this stuff here up here is actually part of the code. The code is all down here. So let's take a look at that. Now, you haven't seen this with me before. It's libraries. And what are libraries? Libraries are an add-on to your Arduino program that makes the program even better. So, for instance, the Adafruit company has put together their own library to run NeoPixels, and it just makes programming NeoPixels a lot easier because you're using just basic sentences to create functions and displays. So the first library is called a wire library. The good news is it comes included with the Arduino IDE, so you don't have to do anything aside from just writing down pound include wire.h inside these greater than less than brackets. As long as we've got that, we're good. And what that allows you to do is send signal through that one wire to your NeoPixel strip. The next library is called Adafruit NeoPixel. So the Arduino IDE does not have that. So we're going to go grab that right now. We're just going to go to Sketch, Include Library, Manage Libraries. And a little window is going to pop up here where you can type into a search bar the library that you're looking for. And we're going to just click right up in here as soon as we're ready. And we're going to type in Adafruit NeoPixel. Adafruit NeoPixel, and just wait for a second, it'll pop up, and actually it did right here. There's the Adafruit NeoPixel library. You can see mine says it's installed already. Yours will probably have this in bold, and you can just click on it, it'll install it, and that library will be automatically downloaded to your Arduino program permanently. So then you'll just say close. You may have to close your Arduino program and reopen it before it takes effect. But as long as you've done that, it should include both of these and we're ready to go. The next two lines are just set up your number of pixels. So I've got 8 here. I've gone back to 8 because I want to show you this demo with the 8 strip. And then the data pin is number 9, so you could change that to whatever you want to plug your NeoPixel strip into. This third line here just names your NeoPixel strip. So every one of these strips should have a name. In this case, I just call it strip, but you can call it my NeoPixel strip or strip number 1 or whatever you want. So just name it right there. And then the next little section here in brackets, it says NumPixels. Well, that's the number of pixels that you've already told it right up here. So an 8 would be in this spot right here. The data pin is number 9, so we've got that set up. And then this is the type of NeoPixel strip we're using. So that should just remain constant like that, so you don't have to change that. In the setup, we've got 3 things that we're setting up. We're beginning the strip, so what you have to do before you can use this is to type in strip.begin, and then strip.show sets all the pixels off to begin with. And then your brightness level, you can choose what brightness level you want. I've just set it to 100 right now. Remember, the more brightness you have, the more power it's going to also consume. Okay, in our loop, we've got 3 different parameters here. We've got set pixel color and set pixel color again, and then show. So what I'm going to do is I'm just going to change one of these. I'm going to just delete this, and we'll just start at the basics. Like that. The first number is which NeoPixel strip do you want to activate? So we're going to activate the very first one. So that would be pixel 0. The next 3 numbers are your red, green, and blue. And you can set these numbers to anywhere from 0 to 255. So 255 would be bright red, the highest level brightness of red that it can do. And then green will be 0, so no green, and blue, no blue. So what we're going to do is we're going to just upload this, and we're going to watch the strip in the window there and see what happens. Nothing's going to happen because I haven't plugged the battery in yet. There we go. So we have red showing up exactly as it says here. So what if I didn't want the very first one? Say we want the second one. That's going to be pixel number 1 because remember they're counted from 0 onward. Let's upload that. And it should shut off the first one, turn on the second one. Good. So let's copy this line and just go down below, and we'll paste that in here. And we're going to change this to, let's maybe have the third one not be red. Let's make the third one green. So close that off. There we go. So we have the second one red, the third one green. Let's upload that and see if that changes. There we go. So we have a red and then we have a green. So what would happen if I combine colors? So what would red and green combine give you? Let's upload that and see what will happen to that one there. We have a yellow. That's true. So we know that red and green light colors combine to make yellow. So as you can see, there's a myriad of different colors that can be formed. So let me just show you that. And then we're going to move into some pretty cool functions using another sketch. Here's a color code chart for LEDs. We have red at the top and we have blue over in this corner and green down here. So what we just did is we combined our red and our green and we got yellow. If you combine red and blue, you get a magenta color. And then you have all these other hues in between. What you can even do is find these online and it'll tell you exactly what numbers to type in between 0 and 255 for red and for green to get a combination of these colors. So that's just some information you might want to check out as you are adding colors to your functions. I'm going to show you a very cool sketch from the Adafruit site. It took me a while to figure this out, so what I did is I color-coded it in Word here so you can see the different parts of the sketch, and that way it'll help break it up and then help you understand exactly what's going on here. So basically, this first part here is what I've already gone through with you on the last sketch. Now the loop has a whole bunch of different functions you can choose from. You can turn these off and on. And what I did is the very first line of each of these sections, I've divided them with these little breaks right here. Let's take a look at this first one. The very first line is one that you want to keep commented. So keep the 2 slashes at the beginning. And it says it will fill the panels one after the other with a color. So if I want red to be included in this, I will just go to here and I will take off the 2 slashes, and then you will get that particular part of the function working. And what it will do is it will fill in the whole strip with red one after the other. And the 4th number, this 50 right here, that one there, it's going to set the speed of that. So it's going to start at one end, go all the way across at 50 milliseconds between each of the NeoPixels. So pretty cool. How does it do that? How does it know how to do that? Well, here where it says color wipe, that color wipe is a function. And where the function is it's way below all of this and past the loop. Here it is right here, color wipe. So it's going to jump down and say, what is color wipe? Well, it's going to do everything from here to here, way up at the top there where you told it to do color wipe. So it's just, this is the program for it to swipe through that color in red. Now, when you go back up to the top here, color wipe, if you want it in green and blue or white, then you just uncomment these as well, and it'll do them all in order. You can even put delays in between them, so there's say a 1 second delay, so you can watch it take its effect. So that's really cool. That's color wipe. And if you didn't want that function, just put the 2 slash marks back in, and it will just ignore all of that. Okay, the next one is theater chase. If you want the red to be in theater chase mode, which is a theater style crawling lights, you would just uncomment that like this, and then it'll say, okay, theater chase, I'll do it. Let me go down and figure out how to do that. So here's theater chase. It will do everything from here to here and go back up at the top here, and you can do that for the green, the blue, the white. Now you can also add in here, add this back in, you can add other hues in here. You can just copy this line and underneath paste it, and you can change it to 255 and 255 to get yellow or whatever you want. The next function is rainbow. It fades through all the colors at the same time. So there's only one line for that. You just uncomment that, and rainbow 20 would, you just go down here, and 20 is the speed, by the way, and you go down to rainbow, and it does all of this for rainbow. And then the next one is rainbow cycle. It fades each pixel separately through the colors. So this was all at the same time, and this is separately. So rainbow cycle. And then theater chase rainbow is theater style crawling lights with a rainbow effect. So there's a whole bunch of different effects here, or functions here. And what you'll find is that they're all sitting down below here. You'll also notice that there's something at the very, very bottom, and this is the color wheel. This is how it knows how to go through the colors in a certain sequence, but you got to leave that in there as well. We're going to go take a look at this and activate some of these in our actual program. Let's take a look at this in action now. I've got my NeoPixel strip right up there, so you can check out these functions. What I've done is I've put a 1 second delay in between color wipes. So we're going to just take the comments off of these lines here. And we're going to leave white commented. And let's plug in our battery pack and check out what color wipe looks like. Here we go, red, green, and blue. And we can change the timing between them all just by adjusting that, but we're going to leave that for now. And it's just cycling through that because none of the other functions are enabled. So let me just put those back in, and we will try out theater chase. How about maybe in green? So let's uncomment that and try going to upload there and watch theater chase. So there's theater chase. We can change the speed of it. Let's set that up, and there we go. That's a lot slower. So if you want that effect, Theater chase is a good option for you. Okay, let's comment that out and try rainbow. What this will do is it'll go through all the colors at the same time. Pretty cool effect. And there we go. You can see it's just pulsating all at the same time. So that is rainbow. Let's go down to rainbow cycle. Okay, rainbow cycle, upload. And this is each pixel separately, so you can see the myriad of colors forming. And remember, if you have some kind of a covering over it, different effects you can get are pretty cool. All depends on your translucent covering. So that's another option for you. So let's comment that out and let's try Theater Chase Rainbow and see how that looks. So this is crawling style lights where they're changing colors as it cycles through. So there's a bunch of functions right there. You can mix and match. You can change the hues on all of them. And then you can add other sketches into this one as well. So we're going to go look at a couple more before we finish up. So stay tuned for that. Here's a Twinkle sketch that I put together. You're welcome to that as well if there's a link in the description below. It just turns on and off these LEDs on this strip here in random order. So it makes a really cool twinkling effect, and you can speed that up or slow it down. And finally, I'm going to show you fire. This is a really great fire effect, and this website that I found the sketch at is called tweakingforall.com. Really great guy. He's provided a bunch of NeoPixel sketches for you to use. So I'll link that in the description below, but it's a really great effect, and you can tweak this. You can make it faster, slower, and change the colors, but it's a really great fire effect. If you want to see where I've used NeoPixels in my project, just check out my channel. In the meantime, look at this video. I use them a lot in a Droid base station that I built. Next time, we're going to be looking at this little device. It's called a DF Player Mini, and it will add sound to your projects. Until then, God bless you, and we'll see you next time on Learn Animatronics.